what algorithm gave us first, key metrics. So first of all, when I drew the scatter plot, somehow it came like this at many different. These are basically 24 time intervals, sir.
Yes, sir. Yes. Okay. I got it.
The spread is like this, and then when I ran the algorithm, so it gave R squared score a 0.915, which is reasonably good, and adjusted R squared score also 0.914. Yes, and then other key thing is probability of statistic, probability, the p-value is 0.00, I mean close to 00.
But there are multiple categories, right, in this column, so it is not reliable. That p-value is not reliable.
Okay, yeah, agree, sir. Agree. So here, if you look at this one, at least there are some instances where probability was very high, but otherwise remaining are all good.
Yes, and yes.
Remaining all good. And then going to the this one, overall probability omnibus, this one, and then yeah, that's how it is. And then other key summary is you ask us to always draw this one, right?
Yes.
So observed values versus predicted values. The spread is something like this.
Yes,
and then the standard deviation distribution of predicted values versus residual values. So the spread is like this. And then if I look at it, the 2 lambda, if I look at at least good number of them falling into 2 lambda.
2 Z score.
Residual, 2 G score. So considering that, at least the prediction seems to be okay.
Okay, yes, sir. Yes, sir. Yes, good, sir. Good.
So only key difference is, sir, as you said, and also Balabhaskar also and Keshav sir said in the weekend. So I just increased the size. That's the one.
Data set size, yes.
Then yes, I think it became better prediction. Sir.
Yes, sir. Good, sir. Good. Let me share my screen. And today, right, we are into the core of AML. Okay? So today we will learn the complete end-to-end process, I would say. This one, this is what we follow from now on. Or when you get a data set, when you take a data set, this is what you need to do. Whatever I am explaining today is what you need to do, right, from now on. So we are into scikit-learn. That means we are into machine learning. Okay, till now we were actually trying to understand statistics and then bridge it, right, to machine learning and all that. To get more understanding, so I actually kind of did this whole exercise, and let me try to open some diagram. I think I already showed you this diagram.
Sir, one question before that. That Melbourne housing price problem, that input data you mentioned, it's there in some link. Can you put that in the data if that is okay with you, sir?
Yeah, that's the data may be huge, so downloading it is better. Kaggle is the website where the computations will happen.
Okay. Or at least if you can share the link in the WhatsApp group or somewhere, maybe you'll pick it up from there.
Yeah. So Kaggle is the website where you need to register, you need to sign up. Right? From there you can download the data sets. Register is in Google also, Gmail ID also you can register, and there are many data sets in there. You can take them and practice and all that. Okay, and there will be competitions also conducted on data science and AI ML project. So I'll put that in WhatsApp.
Sure, thank you, sir.
So I think it is there on the website also, right? So if you go to datajango.com, you go to the step-by-step data science project. You did not keep it here. Yeah, just Google it, you will get it, and I'll put the link anyway. Okay? That's so so from today, right, you need to follow this approach. Let me magnify this. So whenever you get a data set, right, you need to split that into two parts first, train set and test set. Generally, when the data set is small, right, we'll do 80-20, 80% train, 20% test. Okay, this test set, we'll keep this aside, right? Keep test set aside for testing the model, okay, for testing purposes. Why are we keeping this aside? That's the question, right? So we have like 1000 records. We have taken 800 records for training, 200 records, we kept them aside. The first instance itself, you need to keep them aside because when you are doing data analysis, when you are doing this data analysis, you may understand patterns. When you understand patterns, right, you may choose an algorithm, right? If you don't split this and took the whole data, whole 1000 records, and doing the data analysis, you may understand pattern and you may choose an algorithm which may fit to the whole 1000 records. Okay, and then you are testing it in the production, or you are actually using it in the production. When you are using it in the production, right, it may not work. It may have worked on the 1000 records here, but it may not work on the production because you haven't covered the unseen data scenario. Okay, to create unseen data scenario, we are actually splitting data at the first instance and keeping this test set aside. Even we will not look at it as a data scientist. You also will not look at it. Look at this test set. Only you look at 800 records. You try to understand the data. You do the pre-processing and then apply ML algorithm, right? And then, right, you do exploratory data analysis, feature engineering, and then take the algorithm, build a model. You test it with those 800 records, see whether the model is working good or not. Okay, train predictions. You actually pass these 80% or 800 records. In our case, I said 1000 records, right? So 800 records you pass to model. You get predicted data, predicted values of the train set. Y cap you get for the train set, and then evaluate. How do you evaluate? Either you take R square score or adjusted R square score. If it is high, good, right? If it is not high, we may have to fine tune the model, right? We need to actually tweak some of the parameters in the model. So today we may not see fine tuning, but we'll see the rest of the process. So we take the data, we split the data, we do EDA, we build an algorithm, we test, we pass the train set, predict, calculate the accuracy, model is working, then test it on the test set now, right? This test set we will not touch until and unless we see that the model is working good on the train set. Okay, so now you pass your 20% and test it, see the test predictions and evaluate again, right? R square score you calculate again. If it is working well on the test set also, that means model is working good and it has got highest high probability that it will work in the production also, because this is unseen data, right? This test set is unseen data, unseen in the sense, even as a data scientist, I did not look into it, right? And then I passed that to model and made predictions. And I have a way to check, right? If you look at the train data, the whole 1000 records, you have Y value. And here you will get Y cap, test predictions. So you can test it, right? And then see whether model is working good or not on unseen data. But if you don't take this aside and take the whole 1000 records and build a model, and you are using it in production, you will not have a way to test it, because in production you will not have Y cap. Suppose that you are working for a real estate company. You built a house price prediction model. You did not test it while building it, and you are trying to use it in the production. That production in the sense, the real estate company built again 100 more houses, and you need to make predictions. You pass those 100 more houses features because they are there. Price is not there. Just built houses, right? Price will not be there. So you made predictions, you got price, but you don't know whether that is right or wrong, and or how much error is there in your prediction, you will not know. That is one thing. Until the 100 houses sold, you will not be able to assess whether model is working or not. Right? That's the problem. That is one problem we are trying to solve by taking the test set aside. The second problem is when you take the whole data and try to do feature engineering and choose algorithm because your mind already understood patterns that and the model may be working on train set well and not well on the test set. That is called as data snooping bias. Because of data snooping bias, it happened. Okay, so there are two points or 3 points actually. I'm going to talk about two now. Third one I'll talk once I show you the code. The first point is in production you will not have a way to test the model. Okay, so you need to take some data, right? Test in a production like environment we are trying to create. Production like. What is production like? Unseen data. You have never seen the input data or the output data, right? You have created the production like environment. That is one thing. The second thing is if you take whole data and try to analyze it upfront, as a human being, you may understand patterns and you may choose algorithm which is appropriate for this whole data. Okay, and there may be some hidden patterns. You will not be able to capture those hidden patterns when you actually take the whole data. But if you put the test set aside, and if the test set, the model is not working on the test set well, then you strive to make the model work well on the test set also. That way you will know the hidden patterns also. Got it? Any questions? Any questions? Why are we splitting the data into train and test? We are good, right?
Yes.
So data snooping bias and production will not have, you will not be able to test it in production. Third thing is when we are doing data pre-processing, we were actually writing some code, right? For to exploratory data analysis and feature engineering. Basically, exploratory data analysis code may not be needed in production or test, but feature engineering code is needed. What is feature engineering? You have a date built. You actually extracted year built from the column. That's some code, right? And there is
Adding interaction terms.
adding interaction term comes under algorithm, not the feature engineering. Algorithm is actually, if it has a interaction term, right, we will add it, rather we will not add it. That's an algorithm thing. But when you are manipulating data and creating new data, right? If the first example is from date built, you extracted year, right? That is one manipulation. Or there is a width and height of the room. You have calculated area out of it. Two columns are there, width and height. Maybe total house. And you calculate area of the house and you removed width and height columns and kept area of the column to reduce the number of columns. From 2 you calculated 1 and kept in the data set. Sometimes when you actually do feature engineering, the model predictive power improves. Okay, I forgot those scenarios.
Is this not the interaction term? Like there are x1 and x2, and we are multiplying x1 x2, right? It's an interaction term, right?
Oh yeah. Interaction term. Okay. So I was actually in an impression that this intercept. I thought intercept. Sorry, intercept is a sorry. Intercept is algorithm thing. Okay, interaction term yes. Interaction term yes, but algorithm can actually create that. Yes, interaction term is one of the feature engineerings, but algorithm can create it manually. We may not be able to. We may not be needed to create it. In some cases, right, we divide and all that, right? We actually kind of extract. Interaction term is one of them, feature engineering thing. But algorithm can do it. I'll show you when I show you the polynomial regression, right? I'll show you. I was confused. I'm actually thinking somewhere and talking here. So intercept, I thought. Okay, intercept is a algorithm thing. Good. Thank you for raising it again. Okay?
Yeah, thank you, sir. I was just confused. Yes, sir.
No, good. Sometimes Somewhere else I'll be talking here. Okay.
Yeah, not a problem.
Yeah. So here, the other thing is, right, while doing that feature engineering, you will write some code. That code is needed in production also. So in this, on this unseen data, you did not apply this feature engineering, right? So you need to apply that feature engineering to make the model work. Yeah, one of the things is converting categorical columns to numerical columns. Okay. Suppose that you did label encoding of this train set. Okay. One of the columns you converted to numbers. But if you look at the test set, right, you did not, you actually took this test set and kept aside, right? You used it here. So in the test set, right, in that particular column, you will have categorical values. So you need to apply that feature engineering onto that categorical column also, right? So that way you are actually testing your code. Whatever code you wrote to do feature engineering before you apply algorithm, that code is being tested on the test set before you move it into production. Sometimes you will find some patterns where it will throw error in the test set. That means the sampling did not happen on the train set. The split, when you did the split, right, the sampling did not happen properly. So I'll show all these things. Before we go there, right, I'll talk about one important concept: underfitting and overfitting. In every interview, the common question: underfitting and overfitting. What is underfitting? What is overfitting? When model is working well on the train set, and not well on the test set, you call that as overfitted model. Okay. When the model is working well on the not well on the train set itself, then you call that model as underfitted, right? So you trained a model on a certain amount of data. The model is not working well on that certain amount of data itself. It is called as underfitted. If the model is working well on the train set and not well on the test set, it is called as overfitted. If it is working well both on train set and test set, then you call it as a balanced model. So we need to bring model to a balance. That's another task for a data scientist. So I'll take this example generally. Right, it will happen to many of us, right? No? Especially maybe at least to me, it happened. Right? In our childhood, when we were in the hometown, we'll have many friends, and we'll be roaming around and having fun. But when you come to the city, right, you will have people, you will not be able to mingle with them. So that is an overfitted situation, right? Because the hometown people, your friends are good, so you are able to mingle with them well. But when you came to city, right, these people are like like you only. So you're unable to mingle with them. So that's kind of overfitted situation, right? Your mind adjusted well to the scenarios which are present in your hometown, but not in the city. On a larger data set or an unseen environment, your mind is not prepared. That is called as generalization. Your mind generalized well, you would have been mingled well in your hometown as well as in the city. But your mind is not tuned like that. It is actually constrained by your own thought and whatever that environmental situations. You will be behaving well in the hometown, but not in the city. That is overfitted situation. Overfitting means to a particular environment or to a particular condition or to a particular data, your mind is working well or your ML algorithm is working well. Your mind and ML algorithm are similar things. Okay. Only certain data, certain information, certain environment, your mind or ML model is working good. That is called as overfitting. If it is working in your certain, the controlled environment as well as in the production or the test, then you call it as balanced model. When your brain is not even working well in your controlled environment also, that is called as underfitted. You are unable to mingle well with the people in your hometown also, right? That is called as underfitted model. I think to remember well, I am actually trying to take this example. Right? Did you get that underfitting overfitting concept? Anyway, we'll be talking about this many times. Did you get it?
Yes, sir.
Okay. So evaluate using error matrix. Check for underfitting. The model is working well on the train set or not, because this is a controlled environment. We actually try to build a model. We are testing it in the controlled environment itself, controlled data, the limited amount of data. Even there, if it is not working well, then underfitted. Then you need to do something about the feature engineering or data collection, or we'll actually analyze that what you should be doing, right? And if the model is working well on the train set, you pass your test set and see how it's working. If it is working well, then your model is good. If it's not working well, it is overfitted. To reduce overfitting, what you need to do also we'll see. Okay, this is the whole process of executing a data science project. I'll upload this image also. Okay, this is the whole process of executing a data. We'll be looking into all individual components here and more algorithms. So what we will do is total process we'll see, and then we'll be understanding more algorithms. So you need to change the algorithm. That's it. The process will not change. Only the algorithm changes. Okay. So let us jump into the code and see. Right now I am into scikit-learn, sklearn. Right, when you install Anaconda, right, everything will come with it. Pandas, NumPy, Matplotlib, Seaborn, scikit-learn, all these things will come. So here I am using linear regression algorithm. So this linear regression algorithm, we already saw a OLS, ordinary least squares. Now we are looking at linear regression. In maybe a week, right, we will be seeing SGD regressor, stochastic gradient descent regressor. So three variants are there. Why three variants? Especially we look into this linear regression and the SGD. Why two variants we look into? Okay, so there is a reason for two variants of the same algorithm. Okay, so I am importing all the necessary modules here. You all know these, and then scikit-learn has got many modules. Right, linear models. Linear model is one module where you have linear regression. And model selection is another module where we'll have splitting data, right? Shuffling and splitting data and data sampling mechanisms implemented. So let me execute that. And now the data set shape. So I have created, this is synthetic data. I have generated this data to explain you the concepts. Once we know the complete understanding of the execution process, right? We'll get into datasets, or you can actually take datasets and work on them now. After looking into this code, right, you can take Melbourne dataset and work with it. So you say, see this Melbourne housing data Kaggle, dataset Kaggle. You will have. I already registered, so I am not signed in. You need to sign in and download. Right? It's a 2 MB data. I think I can download it. Give me 1 second, I'll put it there. I think 2 MB only, so. Yeah. So I actually kind of, yeah. So how much size this is? Yeah, 2 MB only. So let me rename it and put it in the we will put it in the drive. I think we should have it in the drive also. I'll put it in the drive. Okay. So there are that data set you can work with. Okay. So I have taken this data set and to explain you concepts, because there are many things here. So I created synthetic, categorical columns, synthetic numerical columns that look like, that are categorical columns that look like numerical columns and things like that. Okay, so I'm looking into head. So I started this process. Okay, I took the data, I looked into head. Okay, and then now why am I using seed? I don't know why am I doing this. Somebody would have asked a question and I would have done this. Okay, I'll explain this random thing in a moment. So I took the data set and then I'm splitting the data into train test. So the next step is I'm splitting the data into train test. So to do that, we have tools here. Shuffle split is the method. Okay, randomizers for shuffle split, k-folds for shuffle split, different classes are there. Okay, you can look into them. So the shuffle split, what it will do is, it will take these 1512 records, it will shuffle them, right? It will actually shuffle them a lot, and then try to take 20% as test. So in the shuffle split, n split is equal to 1, test size is equal to 0.2, random state is equal to 33. I'll explain what is this random state in a moment. First understand how the split is happening. Okay, so n split is equal to 1, I said, right? That means you are breaking the stick into two parts. You need to make one cut, right? So that is split 1. And then test size I specified as 0.2, that means 20%, right? 20% of the data I'm taking as test set. On a moderate data set, you actually try to take 20/20/80. But if the data set is having 1 million records, right, you will not do 80/20. You will take 10,000 records aside and take the rest of the data for training. Generally, training needs more data. Or how much data you pass while training the model, that good the model is going to be. Okay, I have another example for this also. You are a manager and you have been handling a team of 200 people now, and company is very comfortable in giving you a 500 people team, because you are already handling 200 people, right? That means you have worked with a huge volume of data, or huge many brains, right? So you will have capabilities to work with even more size. But if you are working with only 2 people, 3 people teams, and a company may not try to give you a 500 people team immediately, because your training was done on a small data like that. So whenever you are trying to build a model, try to provide more data for training. That way the model will work better. Our model will generalize well. So this is another example. I'm going back to the hometown and city example. So hometown, if you have like around 100 friends, most probably you will be able to survive in a city also very well. People mingle very well, right? Some people mingle very well with people, right? Other people, they can survive anywhere in the world, right? So some people are very restrained and constrained, so they will have face problems in other areas, because the number of people they interacted with is less, and when you interact with less people, right, most probably generalization happens very less, right? So that's the kind of thing. The machine learning algorithm is like mind. So you need to give as much data as possible while training. So in general scenarios for small data set, when I say small data sets, maybe 10,000 to 50,000 records, right? Even 1 lakh, 100,000 records, you will do 80/20 split. But if it's beyond that, right, maybe 200,000, maybe 1 million, you will generally take maybe 10,000, 20,000 records aside, keep them aside, use rest of the data to train the model. But while splitting the data, right, you should be careful, right? While splitting the data, you should be careful. What is that? Why I said you should be careful is, suppose that it is Hyderabad data, right? Hyderabad real estate data, and we have got the data set, and we have to split the data. What I did is, I took all Banjara Hills data as test set, Banjara Hills and Jubilee Hills data as test set, and took rest of the data as train set and built a model. Will the model work on test set? I have a question.
No, sir.
No.
Why not? Why not?
Because that's a costly area. There are so many other areas of different ranges.
Yes, right. So the sampling did not happen there. While training, you took a certain kind of data and trained your model, and you are trying to test the data with the other kind of model. That means sampling, we call it as. Okay, data will have different patterns. So when you are sampling, right, you should make sure that all different patterns are covered in the train set. Got it? It is like training a guy to play cricket. Right? You need to teach him all kinds of balls, right? If you are trying to make him a batsman, you need to train him on spin ball, fast ball, Yorkers, and all that you need to experience while training. So the data should also be like that. So you need to make sure that all the scenarios in production data, in population, are covered in your train set or not. When I say train set, right, the splitted part. Generally, we call this whole thing as train set. But we split it and call, the first 80% as train set and test set. That's a confusing thing. Okay. So it is a terminology used in industry, but it's a confusing thing. So this whole thing is train set. That whole train set you take and split it into train test again. Use the train set. Make sure that this 80% has got all different samples, all different kinds of samples in it. The sampling importance is that. So there are two sampling techniques I am going to cover, which generally work. One is random sampling, and second is stratified sampling. Okay, I'll talk about stratified sampling later when we cover classification. Right? That example is very simple to explain there when we cover sampling example, so classification example. Here I am covering the random sampling. Generally, random sampling works. So if you do shuffle split, right, what happens? It is just shuffling the data and taking 20%. So most probably you will not get Banjara Hills, Jubilee Hills data. You will get some data from Miyapur, some data from Chandanagar, some data from LB Nagar, like that, right? So this is random sampling technique. First thing is that when you take the whole data, the data sample should be right. Okay, that is first scenario. First care you should be taking while collecting data. The second thing is you should be doing the split appropriately. The sampling should happen very, very well here also. On the train set you should have, in the train set you should have all different scenarios covered. Maybe similarly in test set also. Basically the sample should simulate your production environment. Okay, so now I took shuffle split. I specified how to split it. I'm going to talk about random state in a moment. Right? And then for train index and test index, it's a generator, we call it as. Okay. When I say generator, right, it's going to bring data while the loop is running. It is not like in a single shot it will split everything and give you the indexes. While that loop is running, right, it will actually try to pull out indexes, and I actually took the train indexes and test indexes and I'm showing them here, I think. Okay, I'm showing them here. So I splitted the data here, right? Employee data, LOC, train index. So if you don't specify columns, right, it will take all. Okay, rows I specified, row indexes I specified. So this is how you split the data. Okay, any questions here? So I have taken train set some indexes, test set some indexes. I printed indexes there, but I took the data, splitted the data like this. Okay, any questions here?
That random state 33, can you please explain that once again?
I'll explain. Any other question?
Sir, why we are using the for loop here? I didn't understand
Yeah,
that. Why we are
that's the thing, right? I think, yeah, this is the yield, right? When you actually in a function, if you say return, right, this is actually a function, right? Your question is very right, Lakshminarayan. When you are using a function, generally the function should be used like this. Function should be used like that. Maybe it is returning two lists, a train index and test index, and then maybe you are actually trying to pass this to LOC like this. You should be using. But here, this is your question, right? We should be using like this.
yes.
Right? Why did we kept this split in a for loop? That's the question. Actually, I was actually about to skip it. I said that it is a yield method, right? It's a generator, not a function. And I was actually trying to go forward. That's a good question. So when the function is a function, right? it generally returns the values right away. Okay, what is the disadvantage? If in your data set, if you have 1 million records or 1 million records, right? And if the index is of float size, float 64, each number is a 64 bits, 64 bits, right? 64 bits means how many bytes? 8 bytes, right? 8 bytes. Okay, let me try to calculate that. 8 bytes each number, and then we have 1 million numbers, right? 6 zeros. We typed 6 zeros, yes, right? And divided by 1024 is kilobytes. Divided by 1024 is megabytes, right? 7 MB it is. Okay. So in some cases, right, what will happen is each record will be of 4 MB or 8 MB. If you convert a picture into pixels, if you convert a photo into pixels, generally it's going to be around 4 to 8 MB. When the image size, each image size is 4 to 8 MB, you are trying to loop through and get something, right? You are actually trying to maybe filter some images and get into some variable. You may get a 500 MB sized, 500 MB sized variable, or the object which is of 500 MB, and you need to hold it in a variable, right? Your memory will not be sufficient, so your memory may, out of memory error may come. When you are using a function, what's happening? It is processing everything and sending you back in a single shot. If you have 1 million records, this variable is going to hold around 4 MB sized object. But if it is a case of a image, many images, and you are processing it, you processed 1 million images and trying to get it into a variable, it may occupy too much space and you may get out of memory error when you use functions. To avoid that problem, there is a facility called a generator in Python. What generator does is, in a loop, it actually sends back one at a time. In a function, everything gets processed and it actually sends back. Okay. In generator, every iteration it will actually process and send you back one value at a time. So that's where we are actually calling the function in a loop. When you call a function in a loop, right? First iteration will bring 2 numbers here. Second iteration will bring 2 more numbers. Third iteration, 2 more numbers. Fourth iteration, because you used yield here instead of return, you used yield. Yield keyword makes a function a generator. Okay, you might have got a little bit of idea. Okay. Let me try.
I got the idea.
Yeah, you got it.
Kind of pagination, you can say. It's loading one by one, right?
Loading one by one. In a loop, the function will work like a loop, basically.
Yes.
Function will work like a loop. So I don't know whether I gave proper examples here or not.
No, I got it. Oh, yeah.
Yeah, this function length of a string, and then see this here. So in a function, right? If you try to, this is not very appropriate example, but so what am I doing? Range length. What is this -1? Length -1. -1. Okay, I am actually reversing the string, I think. So if you look at the difference here, return, this function, whenever you call return, right, it is actually coming back. So if you call this function in a loop for character in function, right, and then you passed hello, I am calculating the length here, and in the range of that length -1 is length is 6, so index is going to start from 0, right? So I did length -1. The -1 is the step. The -1 is the index, and this -1 is step, I think. Okay, let me try to.
Yes. Yeah.
Yes, first middle -1. Yeah.
Maybe
Index. Starting from the last letter.
Yeah.
That is step. Last one is still.
Let me try to see. There is one more thing in Python. If you don't need I, right, you can put underscore there. You don't care what is coming from this, right? You put underscore there, and then you can use print or whatever. Okay, but I need it. So I'll print it. All right. Did not give anything. Maybe I should give -1 also here. Yeah. So stepping is needed. So it is actually starting at 5 and then it is stepping 1 -1 -1. So it is returning, right? So when you use return, right, it took the last index and just came back. That's where you got O only. Hello, O only. But in a yield method, right, what is it doing? It is taking this, going here, right, and then calculated the length, and it took the length and reversed it. This yield actually kept everything there and returning one at a time. So it got the 5th index one, then 4th index, then 3rd index, then 2nd index, then 1st index, like that, right? This yield is the key there. This yield is the thing which is actually making it work like a loop. The function is actually giving you one value at a time rather than giving all at a time. Instead of here, instead of returning this last index, right, if you do some processing and send everything at once, all will come at once in return, but yield one at a time will come. Okay, this is called a generator. When you use yield in place of return, that is called a generator. Okay, this is a generator method. That's where it is actually returning one at a time. This was designed in this way because sometimes you may actually load huge volume of data and then you try to process it. Okay, I think you got it, but still I am going on explaining. Any questions? Any other questions on that? Good. So random state, right? This random state is going to be there in all the most of the algorithms in scikit-learn. Okay, what is random state? Let us see. In NumPy, there is a method called random.rand, right? np.random is a module. In that random method is there. When you say 10, right, it will give you 10 random numbers. When I execute it, right, see that if you look at these values, right, they are changing. Right? They're changing. If I want to generate those random values at the first execution, okay, generate those random values at the first execution, and then from the next execution, I wanted to have the same random values. I need to set the seed. Now, when I execute multiple times, see that same values are coming. When I'm executing multiple times, same values are coming. Because of the seed, it is happening. Because of the seed, it is happening. What is the seed? Generally, this random method will have some formula, right? Some formula to generate a random number. Using that random number, it will generate these numbers. Right? When you have to, if I ask you to write a program to generate random number, what you will do? If I ask you to write a program to generate random numbers, what you will do?
Maybe we'll fix the range into which we need to get the random number.
Yes, sir.
Then maybe keep on, let's say, adding one number to some predefined number, and then whichever are used, take them off.
Yes.
And then go on the remaining So something.
You have some logic, some formula, right? Right. So the guy who actually built this random method also, he actually implemented some logic to generate these random numbers based out of one number. Right? While generating this random number, there is a formula in which there is one number which is called a seed. Okay. If you don't set seed, that seed will also be generated randomly. That's where when you execute multiple times, you are getting different numbers when you don't set the seed. But when you set the seed, right, the base number you are setting it. Don't generate it randomly. You're setting it. So now, first time it will generate the values randomly. From next time onwards, same numbers will be generated. So for this seed, right, it will generate the same numbers, right? If I change it to 20, okay, it is generating the same. You look at this number, you will understand. Okay, generating this again 23. See that same number, right? Again, I will go back to 20. See that same number. So there is a base number, right? It is like you know 2000 into x by y by some formula is there, right? So you are setting that seed, right? That whatever the seed number. So there are two formulas, one to generate seed and another to generate random numbers, the range and all that, whatever Giri said, right? So we are fixing that base number by setting the seed. This seed is nothing but the random state in scikit-learn. What we are doing is we are setting a base number to generate these train indexes and test indexes. Right? If I don't set this seed, right, what will happen? First time you execute, you get different train set, different test set. Second time you execute the code, you get different train set, different test set. Getting it? If you don't set this seed, this random state, n number of times you execute, n number of different train sets, n number of shuffle splits will happen. Got it?
Sure.
Right. What is the problem with that? Do you see any problem with it?
If you want to send the data to the remodeling, then it will always change.
Good. Right. What's happening here? You are splitting data into train test. You are using this 80% and trying to build the model and checking whether the model is working good or not, and using this test set to test whether the model is working good or not. But every time this train set test set split changes, right? Every time you execute, you will get a different score here. You don't know whether the model is working good or not. The point is, you executed on your computer, it gave 99% accuracy. Right? You are happy and you took it to your manager and executed, you got 70% accuracy. No, you'll be in soup, right? So that will happen. So that's where you need to fix the seed while doing the split. Okay. So when data set is huge, when you fix the seed, give me one second. When you fix the seed, generally the model will work well. But data set is size is small. You fix the seed. For one seed it will work in a different way. For another seed it will work in a different way. For one random state it will work in a different way, and for another random set it will work in a different way because data set size is small, right? If data set size is big, right, you will not have any problems. The key for machine learning to succeed is how big the data set is, that good the models are going to be. Go ahead. Somebody has got question. So somebody was asking about to ask a question.
Yes, Narayana, Rama. So here random state is 33. Right? 33 is like constantly like we need to, by default we need to provide, or we can give any number.
Any number you can use. Any number you can. That's what I am saying, right? If you put 20, the split is going to be different. See this? Train index has changed. Okay. If you put 33, the split is going to be different. See that?
Okay.
Right? So when your data set is huge, any number you can take. The random state, any number you can take and split it, but you need to fix that random state to one number. You shouldn't be changing it, quite often. If you change it, the results will change if the data set size is small. If data set size is big, right, it will not change. Because sampling will happen appropriately. When data set size is big and you chose very consciously the data set, then the split will happen properly and the model will work well. Okay. Yeah. So we are here, till we are here only, right? So we are splitting the data because we know most of it. Whatever we have seen in this area, right? We have already seen with other things, but here this part we did not saw before, right? So why splitting? To avoid data snooping bias, to test whether model is working good in production or not. We are actually doing that split. first thing you need to do is split the data. Many of the articles will not talk about this because they don't have that understanding of how to test the model. Okay, so this is very key, very important thing. So now the train set has got 1200 records, test set has got 300 records, 303 records. Now this is describe method. I think I explained it in the pandas class. So when you look at when you have too many numerical columns, if you use describe method, right, you will get a kind of understanding. We are doing exploratory data analysis. We want to understand data. So any outliers are there, any column is behaving not properly. If you want to see that, right, so you can do describe. See describe quartile 1, quartile 2, quartile 3. It looks good. Maximum 20, minimum 0.2. This is experience. Okay, that looks good. And experience should not be 200 years. 20 is good. And then 1209, 1209 records are not nulls. So there are no nulls here. Right? Salary also, it looks okay. Right? If you look at standard deviation, it is 3. Right here, here the maximum is 20, minimum is 0.2, standard deviation is 3. Within you can take this mean is 8. Right, within one standard deviation, right, 8 minus 3 is 5, 8 plus 3 is 12. Within one standard deviation, it looks like good, right, kind of in a proper distribution, it looks like, right. You can actually get that idea by looking at describe. You can get that idea. And then aggressive behavior score also looks good. Activity score also. But some people have got 0 activity score, may not be, right? So everybody will be doing some activity. So there is some 0, that means maybe some mistake in the data, some error in the data. And lines of code, somebody has got negative lines of code. Somebody wrote, maybe somebody would have deleted 748 record code, lines of code, and then we said that I'm trying to make fun. So negative number should not be there in lines of code, right? A person, how much coding a person did, Python coding or Java coding or C coding or whatever. A person should not have negative number. That means there is something wrong with this column. So when you look at describe, you will get that high level picture, and you can focus on the columns which you may think there are problems. So I took lines of code and I'm actually trying to filter the records which have got the score less than 0. So I kept less than 0 here. I got a series object with falses and trues. Now I am filtering the data frame. I took the data frame, I applied this filter. Wherever it is true, only those indexes will be shown. Right? Wherever it is true, only those indexes will be shown. See that? In all these records, we have lines of code negative. That means data entry error it is. Application is the application which actually collected this data did not collect it properly. So this is exploratory data analysis. We are actually trying to see problems with the data, and when we find the problems, right, we'll fix them. So how to fix them? So what I did is all the records which have got lines of code less than 0, okay, I replaced those lines of code value with 0. Maybe it is 0, right? This is a dumb way of replacing. But if you look at the designations, right, maybe you can find out. Junior developer, it cannot be 0, right? Senior analyst, maybe it is 0 because analyst, that guy may be, maybe business analyst, right? Senior business analyst may not be writing any code, but doing lots of documentation and the process flow diagrams and all that stuff. Okay. So the junior developer again should not have negative. Maybe these are positive numbers and by mistake they went into negative. So if you dig deep into the analysis, right, you may find better values for these. But what I did is I dumb way. I actually took all the negative records and replaced them with 0. Getting it? Exploratory data analysis will show you the problems with the data or make you understand data. Then you do feature engineering. You actually replace values with something, or you merge columns and you try to look at a designation column and try to fix lines of code column. Write some rule based logic to replace values. It depends on the time you have. If you have too much time, you can do all this. If you don't have time, right, you just build dirty model like this and show that this is how it's working. If you have to do a big model, or make the model work better, we may have to do all this other cleanup based on rules and all that. But you may spend 2 more months, but you may get maybe 2% or 3% more accuracy. Previously model may be working 90%. After doing all that activity, you may get 92 or 93% accuracy. But still in some cases it is needed, especially when you look at the areas like online marketing, digital marketing. Even if you get a 0.02 or 0.2% accuracy more, that is very valuable, because people are spending, the companies will spend lots of money. If 0.2% means it may add like 200 users to the, maybe 200 or 500 users to the company, right? So in some cases, very minute accuracy is needed. In some cases, it is not needed. You need to make that decision. How much time you should be spending on feature engineering is a decision you need to make depending on the problem we are trying to solve. Did you get it? Did you get it?
Yes, Ram.
Okay.
Yes.
So,
Sir, 1 second, sir. For the
please.
describe that 75% and all, that is the 75% of the distribution within that experience. Is that what it means?
Okay, sir. Good question. So this is third quartile 3. This is quartile 2. This is quartile 1. At the point at 25% of the data, if you put data in ascending order, right? If there are 100 records, this is 100 numbers. This is 25th number. This is 50th number. This is 75th number. If you put data in ascending order,
Okay.
right? Quartiles, right? Quartile 1, quartile 2, quartile 3.
Okay.
Okay,
So
good question. Yeah.
it means like there is a 25% of data to the left side and 25% of the data to the right side.
No, 25% of the data left side, 75 to the right side of this number.
After 75.
Now after 75, yes, 25 on the right side, 75 on the left side.
Oh.
Interquartile range, we understood, right? That
Yes.
quartile. So this is median. This number is median. This is for the first half of the median of the first half, and this is the median of the second half. Any other questions? Okay. So the filtering is useful, very useful in data analysis and curation. Okay. So I filtered it, and I am looking at the indexes where this condition is being satisfied, and then I took all those places and trying to replace with 0. See this data frame dot loc, and then I took the indexes, right? When you say the index dot value, it is going to be a numpy array. At values, it's going to be a numpy array. Dot index is going to be an index object, right? Where this condition is true, all those indexes will come, and then dot values will give you a numpy array. I passed a numpy array of indexes, comma the column I wanted to replace. Okay, comma the column I wanted to replace. So I think I need to execute this again. Give me 1 second. I'll show something. Okay, so here these are the indexes. Right? Now I'll take I am taking out LOC here. What is it saying? So it is actually looking in the columns. I don't know why. Okay, I tried to show something, but I don't leave it for now. Okay, so here you need to use LOC and you need to manipulate it. So 1 second. Okay, this is not working. Previously, it used to work in the old versions, right? On a data frame, if you pass the row index, it used to give you that row. And I used to write code like using row indexes and then a bracket here and a bracket here and update. So it used to throw an error saying that you are trying to update slice. So that is taken out. That's good. Okay, now you need to use LOC and you need to pass the row indexes and the column you wanted to update. So only those places they'll get updated. And now if you see, if you filter, right, all those negative values are gone. Okay, so now we are trying to fix nulls. I looked into the describe outcome. I found some problem in this column. I fixed it and I'm moving on and trying to fix null values in the data. Okay, so I've taken the train set is null any. If you look at this, I splitted data into train test, right? I'm using only train set here. Did you observe? Train set describe, train set lines of code, right? Train set null values, test set I am not touching. See this? I took the train set, right? Doing the feature engineering or data curation. Then I'll build a model, right? Once after everything is ready, I'll use the test set. Okay, so that point you need to remember. Now, right, is null any, you already know. These columns have got nulls in there. So I need to see, right, only null columns I wanted to see, right? So I wanted to see the column names where the nulls are there. Now, qualification, nulls are there, degree, nulls are there, years of study, nulls are there, and education institution, nulls are there. You look into this code, you'll understand there is nothing big there. Okay, so it's just filtering, right? Different ways of filtering. The way I understood, I wrote it, and you can actually do different ways also. Okay, so I actually took only those columns and trying to see what the problems are and all, right? So when you try to do a slice by passing a list of columns, you will actually get the data frame, right? So that's the data frame, and then the data types I wanted to see. Data frame.d types is an attribute which gives you each data type, each column's data type. So only numerical, first we'll fix the numerical column. Okay, the train data, train set, whatever d types, whatever, wherever the nulls are there, I'm actually looking at the data types of only those columns. And years of study is a numerical column where there are nulls. So when I try to do histogram here, it actually is showing that it is not in normal distribution. Generally, if you do QQ plot, right, you will understand better. But generally I use histogram. That's not a big deal. Right. So now the data looks like most of the data is around here, 15 years of experience. So I took mode and replacing the values with mode. Okay, this is also a dirty way of replacing. I can actually look at the designation and I can fix years of study. If the designation is MSc, it's going to be 15 plus 2, 17 years, right? If it's going to be, if it's MTech, right, it's going to be 16, 18 years, right? Like that. I can actually use other column and fix it. When I use other column and write a logic to fix the new column, the years of study, it may create a correlated column, but that's fine. That's not going to harm anything to the model's performance. But it may create a column which is unnecessary. Okay? Either you have your graduation or your qualification or years of study. It may work. Either column is sufficient to build a proper model, but you have two columns. That's it. That's multi-collinearity concept.
This effect will be more if we are filling out more number of values, right?
Yes, if you are filling more values, if there are more, maybe 90% of the years of study is nulls, and you are taking the qualification as basis to replace values in years of study, then it will be like,
The replica of the
replica of that column. That is actually like strongly correlated columns, and it actually creates, it may create multi-collinearity. If other column, one more column is there, which is like when multi-collinearity is there, no harm to the model, but you will have unnecessary columns in the data, which actually adds a lot of work to the processor. Okay?
processing time and the memory.
Processing time will increase. Memory also. Okay. So it looks like not a normal distribution. It looks like there is more people having 15 years of experience. So I took mode or 16 years of experience and replaced that value. So here I am replacing the value, but if you look at this, right, I am keeping that value in a variable. There is a reason. I am keeping this value in a variable with a reason. Okay. I actually found out the mode value, kept it in a variable, and then fill NA in this column. I'm replacing with that value, and in place true I said, right? It's going to replace it. And if you don't put in place true, right, it will actually show the result. When it is showing the result, that means the data frame is not updated. When the result is not shown, then the data frame is updated. That point you need to remember. Okay. So years of study, again, I try to look at is any now. No, false. Value counts. I fixed it right just now, so no nulls there. And when you look at it, most of them are 16 years, 18 years, 15 years, and whatever. Right? 27 years is also there. I don't know how did I create that data. Okay. So the qualification, the next column which has got nulls, I am trying to look at. This is a categorical column, right? Graduation, post-graduation, postdoc, and PhD. Okay, this is a categorical column. There are 4 categories. I am trying to look at the distribution of the data. I did a bar chart here. So most of them are graduation. So I took the mode. Right. Again, I am saving that mode into a variable and replacing it. Fill NA, in place true. Again, degree, right, education. Right now I fixed everything. Right, it is a dumb way of doing it, but that's okay. We want to understand this whole process. We did exploratory data analysis. We did feature engineering, fixed the data. Now all data should be numerical. Let us see. Okay, convert. No, the categorical columns I still not converted into numerical. Just fill the nulls here. Okay. So now these are all the categorical columns. To find out the categorical columns, what I did is data frame dot select d type, which data type you want. Now if I say int also here, float is there. All the columns which are belonging to object type and float type. Object is the string type. Okay. Categorical. Okay, so I wanted to see all those columns which I got categorical. Now I need to convert these into numbers. Right? To convert these into numbers, we have to go with label encoding or one-hot encoding. Okay, so I am dropping this employee number column because employee number column will not add much value there. Right? It is distinct for each column and it is not going to add any value, so I am dropping that column and now doing label encoding. So what is label encoding? Assigning number to each category and replacing with that. So if senior analyst got assigned 5, you replace wherever you find senior analyst, you replace it with 5. 5 here, 5 here. Developer has got 3, replace 3 here, 3 here. Senior developer has got 2, replace 2 here, wherever it finds like that, it is label encoding. So to do that, you need to take the data frame, right? And then I actually took a copy of it, but I'm actually doing experimentally here and trying to show you. So I took a copy of it and then converted my categorical column by my categorical column into categorical data type in pandas. Okay. While converting the column into categorical, I specified all the categories which are there in the column. So designation has got all these distinct categories. Okay. By providing all the distinct categories, I converted in database, right? When you create a column, you specify all the allowed values in the column, right? Like that it is. I am converting categorical a string column into a categorical where I am specifying all the categories. There is a purpose for this also. Tomorrow I'll explain. Okay, this class actually takes around 3-4 hours, but I had to split it into two. Okay, so I converted it into categorical, and then on the categorical column you have got a method called as cat.categories and cat.codes also. Okay, so the cat.categories will show you all the categories. When you enumerate it, right, this is a kind of list actually. Right? When you enumerate it, what is happening? Enumerate will give you index and value, right? You are taking index as the numerical value for the designation. Index as the numerical value for the designation. Wherever you find director, you replace with 0. Wherever you find junior developer, you replace with 1. Wherever you find senior developer, like that. So there is a, in the cat, there is categories, there is codes also. By default, the algorithm, this categorical will assign codes also. You can do this way or this way. Okay, if I say cat.codes, right, it already assigned the codes to each category. You can actually take this and replace the original value like this. Train.designation.copy is equal to cat.codes. Now all the values have converted to numbers. Okay, so I'll go a little faster today, and tomorrow I'll start from here only. Okay, label and coding I'll start and explain again. Okay, give me like 5 minutes and I'll just go through it and try to cover this whole process. And tomorrow again we'll cover the same thing. Okay, so I converted all the designations into numbers. I'm actually trying to automate this whole process. Whatever I did, in a for a column, I am trying to automate it. I created a dictionary of designation, each categorical column and their categories, and then I wrote a method which actually, converting all those categorical columns to numbers. Okay, and then I am trying to look into the correlation plot. Either is there any multicollinearity in the data or not? And then I splitted the data into X and Y. Train X, all the columns, except salary, and the salary column is train Y. So linear regression algorithm I used, fitted the model, and then predicted on the train set. See this here? If you look at this diagram, I went through and built a model and predicted on the train set, trying to evaluate. Okay, trying to evaluate here R square score and mean squared error I calculated. I got 62%, and then mean squared error is whatever. Now I need to work with test set, right? The model is underfitted. Generally, when model is underfitted, we will not go and take the test set. Okay, when model is underfitted, we will not go and take the test set. But to show you the complete process, I am actually using test set here. So now I have to take the test set and pass it to the model, right? So to pass it to the model, I need to apply all the transformations which I applied on the train set. What transformations I applied? Lines of code, I replaced all those negative values with 0. Then employee number I removed. Right? Then all the categorical columns I replaced with the appropriate nulls with the appropriate values, and all the other columns. And then I converted all the categorical columns to numbers. I have to apply all those transformations on test set also. Whatever transformations I did on train set, I actually did experimentally. I am looking into the data, analyzing data, and then finding out appropriate values. If you see here, what value should be replaced with this null? What value I should take and replace the nulls? What value I should take and replace the nulls? I found out those experimentally, right? By doing EDA on the train set, I kept them aside. I'm using same values to replace test set. right? All the pre-processing, what is done on train set should be done on test set to bring the data set to the place where the algorithm used to build a model. Now this test set is eligible to pass it to the model. Now I passed it. Now I tested. It is giving 66%. So model is actually kind of not working well, but not working well on the train set and test set both. Okay. So where the problem is, we need to see. That we'll see tomorrow. Okay. I'll actually reiterate the class from label encoding because it is already 9 and I'm exhausted. So tomorrow I'll reiterate the class, and this is very important class. This is the basis of total AI, right? Total machine learning and AI. This is the basis. Okay. Any questions you can ask. I'll not stop recording.
Yeah, in the label encoding. So I think we are trying to take some codes, right? There are two ways we have shown.
Yeah.
So is it like, it takes some kind of input value and assign that value? Like in a director, it has actually assigned 0.
Your question is it appropriate to assign high designation 0 and low designation a big number?
Pattern. Is it taking some kind of pattern and assigning these values?
Customized codes. Can we give the customized codes here for director?
You can give, but you need to be consistent in train set, test set, and production. Same value should be used.
Yeah. Okay.
Whether you give a high designation 0 and low designation big number, or low designation 0 and high designation big number, doesn't matter. It should be consistent because algorithm will try to understand pattern based on the value assigned to the category.
Okay. So by default, it is taking the index, right, Rama?
Kind of. It is actually, the cat.codes is kind of index only by default. I tried to, simulate and show. I think we can see the different categories and their codes also. Distinct categories, codes, mapping also we can see. I don't know. Maybe I wrote somewhere. Maybe I need to write it again. So I think Seshiram's question is it appropriate to assign 0 to director and 6 to analyst, right?
Yeah, that is one in the specific case, but also, like, are we considering any pattern from the column and then assigning these values?
No need to find a pattern. You can assign any number to any category, but it should be consistent in test set and production also. While applying data transformations on test set, you should make sure you are using the same thing. That's where, see this years of study, right? All these values are captured in the train set and I'm using it in the test set. Like that, you should use the same mapping in the test set also. That way model will work well. Tomorrow I'll explain that. When you assign 0 to director, it will not affect negatively while calculating salary. Based on the target value, the coefficients will be generated, right? So if you assign, the designation low number and the lower person a high number, the coefficient to this particular column, right, this designation will be assigned in such a way that it balances the y value. Supervised learning algorithms advantage is that it always tries to balance the y, it tries to generate an equation that balances the y value. And as Narayana was saying that, right, if you take custom values and assign them, that is always better, because you will have more control over the model. Got it?
Yeah. Sir, I have two questions based on the work what I did earlier, right? So there I always, as I already told you, right, even with the larger sample size, I'm getting the for the categorical problem what I already showed. I am getting predicted value same as the category mean, sir, always, even with the higher sample. Is that what is expected for categorical problem?
No, it is not expected. Data is like that.
No, I changed my 5 data records to 100 records. Still, I get the same thing.
Even if you change 5 records to 100 records, it is like that, the mean is the best prediction, maybe in that case. For each category, the mean is the prediction, maybe.
Okay, so
If
my
you look
question
at data pattern, right, whatever data pattern is showing is what is going to do, what the machine learning algorithm is also going to find. Right?
yeah, fine. So maybe OLS algorithm for categorical problem, it's always using predicted value as mean.
No,
for
it is not.
categories.
It is not. It's a linear regression. It builds a linear regression algorithm.
Okay.
But fortunately or unfortunately, you are getting mean there. That's it.
Okay. Okay, that's fine, sir. Second question is for the categorical problem, what I already showed. Uh, Intercept is always basically there is no intercept value. It's always going through the origin. So any reason or anything?
Data is the reason. The equation was found by the algorithm. That means it solved all the equations and found that final coefficients. So
Okay.
the coefficients are coming like that. The data is the thing, and
Okay.
the problem you are trying to solve is a regression problem. You are trying to predict a number, right?
Right.
And the input variable is categorical, output variable is numerical. Then you say it's a regression problem.
Okay.
That's a
Okay, sir. That's all.
So data and algorithm will, whatever algorithm found, the equation is correct. Is correct in a way. Right? Try to find the pattern, and it found it that way. That's it. We there is no specific importance to the intercept. If it is needed, it is needed. It will find it. If it's not needed, it will not find it. That's the kind of thing.
Okay, sir.
So I'll upload these files and the Melbourne dataset also. Maybe from tomorrow you can actually work on Melbourne dataset. If you work in the weekdays, right, you will have something to talk on the weekend. Keshwa and Balabhaskar are going to be there, and they'll add more value. Right? So by end of machine learning, if you are good at machine learning, right, deep learning will have many things that that needs lots of time and effort. And generally in the batches, what happens is people will be active till machine learning and NLP. Once I start deep learning, right, everybody will actually slow down a little bit. So don't try to be active while throughout the course. Okay.
Yeah, another thing is today, whatever we discussed, as you said, it's important and probably we better revisit and just to get a thorough understanding of that, sir.
Sure, sir. Tomorrow, anyway, I'm going to reiterate only because
Sure.
I did not explain everything completely today. So I have just went because of time, right? I just went like that. So there are many things to understand here. There is how to understand where the problem is, whether the problem is in the data or the algorithm. Right? So that we need to understand. When we understand that, right, we'll be able to move on, whether to collect more data or choose the best algorithm. So tomorrow I'll talk about that.
Sure, sir.
Rama, can you go once to describe method? Describe.
Yeah.
Yeah, here describe years of.
Yeah.
See, here years of study is 1091. Actually, total count is 1209, right?
Yeah. There are some nulls there.
Okay, years of study
There are
nulls are there.
around 110 nulls are there.
Okay, if there is any nulls, it won't take
The
as a count.
count
Okay.
method will not count nulls.
Okay.
It actually using count method there inside.
Okay.
Okay. So let's meet tomorrow.
So in that case, I'm like